Let's be real for a second. If you're building with AI, your security playbook is probably already out of date. Today, we're going to dive into the new signs of an attack, the weirdly subtle indicators that go way beyond traditional firewalls, and into the strange new world of securing AI itself. I want you to forget about stolen passwords for just a moment and consider this. What if the AI you rely on for writing code, for security analysis, for customer support, what if it just started lying? Not by accident, but as a deliberate, targeted act of manipulation by an attacker. This, right here, is the new frontier. You know, for decades, security meant watching network traffic and checking server logs. But with AI, the evidence of a compromise looks completely different. It's not some suspicious IP address anymore. It's a weird, out-of-character output from your model. It's not a failed login. It's a subtle, gradual shift in the AI's behavior. If you're not looking for these new signs, you are absolutely flying blind. All right, so let's dive into our first category, attacks on model output. This is probably the most direct kind of threat, where an attacker's whole goal is to manipulate what the AI actually says, turning the model's own words into a weapon against you. Okay, first up, we've got hallucinations. And yeah, we usually think of these as just a quality problem, right? The AI is just making stuff up. But in a security context, a hallucination is a huge signal. It can mean an attacker is successfully pushing the model way outside its comfort zone, or even worse, has found a way to completely bypass its safety guardrails. And this is exactly why it's so dangerous. An attacker can use this to make the AI ignore its own safety policies, write some malicious code, or even invent fake instructions to trick one of your employees. A sudden spike in hallucinations, especially around sensitive topics, is a massive red flag that your defenses are failing. All right, indicator number 2 is a lot more subtle, and honestly maybe even more sinister. Output integrity attacks. See, here the goal isn't to make the AI generate total nonsense. It's to make it give a slightly wrong answer. So subtle, in fact, that you might not even notice. Think about it. An attacker doesn't need to break your AI, they just need it to corrupt a risk assessment from high to medium or recommend a slightly weaker firewall rule. These tiny, targeted inaccuracies are often a sign of much deeper problems like a compromised knowledge base or poisoned training data. Okay, now we're getting into one of the most direct and, frankly, terrifying indicators. The model starts leaking secrets. This is when its outputs contain things that should never, ever see the light of day. We're talking credentials, customer PII, internal strategy documents. This is a 5-alarm fire. I mean, if you see something like this pop up in a response, that's not a warning sign. That's a full-blown, active data breach happening right now. It means the model has either memorized sensitive data from its training, or an attacker has successfully tricked it into pulling from a restricted data source. And this isn't just a tech problem, it's a huge compliance nightmare under rules like GDPR or HIPAA. Okay, so we've talked about how the AI's words can be messed with. Now let's move on to our second category, attacks on model usage. This takes it a step further. This is all about how attackers exploit the systems downstream that blindly trust and act on those flawed outputs. So indicator number 4 is a big one, insecure output handling. This is what happens when you take the AI's response, whether it's a piece of code, a database query, or a shell command, and you just execute it automatically, no questions asked. OWASP calls this out specifically because it's like taking untrusted input from a random person on the internet and running it directly on your servers. You just wouldn't do that. So how do you fix this? Well, it really comes down to fundamental security hygiene, and there are 4 key steps. First, and this is non-negotiable, you have to treat all AI output as untrusted user input, period. Second, you validate and sanitize everything before it gets executed. Third, and this is so crucial, you absolutely require human approval for any high-impact action, like changing a system configuration or processing a payment. And finally, you audit everything, so every action can be tied back to the prompt that started it. And that idea leads us perfectly into indicator number 5, excessive agency. This is what happens when you give your AI agent way too much power. The ability to change configurations, deploy code, or call other tools without enough oversight. You've essentially created a new, superpowered intern with programmatic access to the entire kingdom. What could possibly go wrong? And what's so wild is that when this happens, it's not subtle. Just look at this. Your normal day-to-day AI actions are down here. But an attack? Whoa, it's a massive spike that sticks out like a sore thumb. You're looking for huge jumps in activity, the use of weird tools it's never touched before, or actions happening way outside of normal workflows. The key here is the classic principle of least privilege. Don't give the AI keys it doesn't absolutely need to do its job. All right, our final category of attacks is a little different. These are the slow burn threats. They're not designed to crash your system overnight. Instead, they operate quietly in the background, eroding the very foundation of trust your organization has in its AI. This brings us to indicator number 6, overreliance. And honestly, this quote just nails it. Treat AI like a junior analyst, not an oracle. Overreliance is the human vulnerability. It's that moment when your team stops questioning the AI, stops applying their own critical judgment, and just starts treating its output as infallible ground truth. And you better believe attackers are counting on this. They know we're busy, they know we're likely to just trust the machine. So they make subtle changes, knowing we probably won't double check. The defense here isn't just code, it's about people and process. It means having clear policies that AI is only advisory. It means robust user training, and it means designing a UI that clearly shows things like confidence scores and citations. And that brings us to our 7th and final indicator, model skewing. This is like a slow motion attack. It's not a sudden explosion. It's more like a quiet poison that works over weeks or months, caused by bad data or biased feedback that slowly reshapes the AI's worldview without anyone even noticing. And this table here shows you exactly what I mean. On day 1, you ask about a risky configuration, and the AI correctly says high risk. But 90 days later, after being slowly poisoned by an attacker, you ask the same question, and now it says low risk. It's been subtly skewed to favor the attacker's goals. The only way to catch this is through continuous monitoring against a fixed, trusted set of test questions to detect that drift over time. Okay, so we've walked through the 7 major red flags of an AI attack. But just knowing about them isn't enough, right? We have to turn this knowledge into a practical defense. So in this last section, let's talk about how to build your AI shield. And this is the single most important thing I want you to take away from all this. These 7 patterns, they aren't just weird quirks or edge cases. They are the new indicators of compromise for the age of AI. They have to be the core, first-class detection categories for any serious security monitoring program you build. And here's your playbook. It's actually pretty straightforward. Step 1 is to collect everything: the prompts, the final responses, any tool calls the AI makes, and the decisions your guardrails make. Then, once you have all that data, step 2 is to detect the signals we've been talking about. Look for spikes in hallucinations, search for any hint of sensitive data in the outputs, flag abnormal tool usage, and track that slow, long-term model drift. When you boil it all down, it leads to one fundamental shift in thinking. Securing AI isn't just an extension of traditional IT security. It's a completely different game. You are no longer just securing servers and networks. You are now in the business of securing behavior. And so that really just leaves us with one last critical question to think about. Now that you know what the signs are you actually watching for them?